In this example, we're asked to use the Euclidean algorithm to find the GCD of these two numbers. So our goal is to find, as I said, the GCD of 5473 with 533. And the Euclidean algorithm tells us to do this as follows. We're going to do successive divisions where we start with the smaller of the two. And I'm going to perform the division algorithm, but I'm going to do it by like old school division here. So 5473, and then just do the division. We're not going to care about the quotients. I mean, you need the quotient to do the division, but we're going to care a lot about the remainders, okay? So here we go. The first one is going to be what goes in here once, right? So this is 533. So 1 times 533 is 533. We subtract. This is going to leave us with what? 143. Drop down the 43. This goes in 0 times. Obviously, that's a 0. And then the remainder is 143 itself. So I'm going to color code this, and I'm going to make this, so let's say green, or let's do blue. Why not? It didn't do it, did it? So let's turn this blue. And then what we do next, the successive division part of this, is now we just add our little division house. And we're going to take this number, 533, and plug it in here, and we're going to do this division now. So 533, 143 goes into 533 how many times? So it's going to be, what is 4? 4 is too many, so it's going to be only 3 times, right? So 3 times 140 is what? 420, and 429. And then we subtract. Now, we have to be careful that we're doing proper math here, so just make sure that you're careful when you do all these multiplications and then all these subtractions. So this is going to be 104, I believe, right? So 533 minus 29, that's 104 for sure. And there's a remainder, so I'm going to color code this one as well. So we've got these successive remainders. Let's make this one red. All right, next step. This goes into now 143. How many times? It goes in once. 104, we subtract. We're left with this time 39 as our remainder. Let's color code that one. We see how this works, right? Color code that one. Let's make that one green. And then we figure out how many times does that go into 104. So 104, 39 will go in, what, 3? Will it go in a full 3 times? So 3 times this is 117, so that's not going to go. It's only going to be twice, right? So then twice, 2 times 39 is 78. We subtract. I'm sure this is riveting to watch, but this is the process, right? So this is going to be, what, 626? Okay, that's our next remainder. Color code it. Let's call this one magenta. All right. Next one, 26 goes into 39. 1 time, 26, subtract, remainder's 13. Color code it. The number's getting smaller, making it easier to do by kind of mental math. Notice how I'm having to do a lot of divisions on this one. So now 13 into 26, but now we can see this is going to go in evenly 2 times. 26, remainder is 0. This right here is the key, right? This tells us we're done. But the Euclidean algorithm tells us that the previous remainder, which is this one, right? The previous remainder, so if you look at this as like a step, like a stairway, the previous step up is the greatest common divisor. So the 0 here tells us we're done, but it's actually the previous remainder that is the greatest common divisor. So we have computed, using the Euclidean algorithm, that the GCD of these two numbers is 13.